Zeal Education Society, redefining excellence.
Hello everybody, myself Suraj Bhosale. I am studying Zeal Polytechnic Diploma in Civil Engineering. Today I am presenting my mini project of the subject Physics. The project guided by Professor Sandeep Bhosale. The title of project is Explain the Does Gravity Impact on the Acceleration of a Rolling Object. So go to the next slide contain. First, define gravity. Second, define acceleration. Third, experiment to prove does gravity impact the acceleration of rolling object. So go to the next slide. First, define gravity. Gravity, also called as gravitational in mechanics, the universal force of attraction acting between all matter on earth. All bodies have a weight or downward force of gravity proportional to their mass which earth's mass exerts on them. Gravity is measured by the acceleration that it gives to freely falling object. So go to the next slide. Second, define acceleration. Acceleration is the rate of change of velocity. Usually acceleration means the speed is changing, but not always. When an object moves in circular path at circular path at a constant speed, it is still acceleration because the direction of its velocity is changing. So go to the next slide. Third, experiment to prove does gravity impact the acceleration of rolling object. Abstract. The objective to find out whether a golf ball's acceleration was impacted by gravity. I rolled it down a wooden plank on stack of books. Time it taken record in on my Microsoft Excel. Purpose to determine if there will be a change in acceleration of a golf ball due to gravity on Earth when rolled down a wooden planks placed at various stages. Hypothesis. I think that the golf ball's speed will be greater when the angle becomes sharper. For example, if you stack a bunch of books on top of each other compared to the same stack of books at a sharper angle, the ball will travel faster on the second than first. Materials. First, golf ball. Second, stopwatch. Third, Microsoft Excel. Fourth, wooden planks. Fifth, protector. Sixth, pen pencil. Seventh, ruler. Eighth, books to stack. Procedure. First, I stack some books and set on side of modeling on the books to create a ramp. Second, I use the protector to measure the angles between the ramp and the floors. I adjust the stack of books until I can get a ramp as close to 30 degrees as possible. Record the final angle in your notebook. Third, I use a regular to mark 10 centimeter intervals along the ramp starting the floor and going upward. Fourth, it set the goal ball at a measured distance along the ramp. Then I timed how long it took for the goal ball to hit the floor. After I get the ball go, I recorded both the distance I let the ball go and time it took for the ball to travel the length along the ramp. Fifth, repeat step 4 at different lengths along the ramp. Sixth, graph your result and put time on the x-axis and distance traveled on y-axis. 7. Calculate the acceleration for the point you tested using the equation. 8. Try this experiment with different angles. So go to the next slide, observation. This is observation table. So go to the next slide, conclusion. In conclusion, the acceleration at each point was almost the same. The resultant variable because of improper timing and a grow issue. Thank you so much for watching to me.
Zeal Education Society, redefining excellence.